And welcome to the Daily Space Weather, the main feature of the Smash News Network, least busted name in news. I'm your host, Dan, a.k.a. Smash-O-Mash, just bringing you the world's most comprehensive daily space weather content and most detailed solar imagery you'll find in the known universe. These are 24-hour videos of the closest star, El Sol, Helios, the Sun, the local yellow dwarf, the closest star, whatever you want to call it. That's the ionized helium in its corona or atmosphere. Here is the 171 angstroms wavelength. That is ionized iron. That is 30 frames per second. And by the way, we have a very high likelihood of large solar flares from that sunspot just down to the left of the Earth scale there. Sunspot 3615 is the most active sunspot group. And the likelihood of an X-class solar flare remains better than average, folks. Yeah, better than average. Pretty exciting stuff. And here is that's just today's imagery there from SDO. That's 171 plus the colorized magnetogram. And let's take a brief look at what's going on planet Earth before we get back to space. So first of all, this is going on. That's a live webcam feed right now. And the Reykjanes Peninsula continues to create new real estate there. So some new cinder cones have formed, and they're getting taller and taller. As the Reykjanes Peninsula eruption continues, it looks like some earthquake activity happening there as well, as you can see the camera moving around as that active lava fissure begins to do some geoengineering to the lithosphere, folks. So also you've got Fernandina has shown a thermal anomaly. Mount Ibu is erupting, producing a 13,000-foot ash plume. Semeru, 14,000-foot ash plume. Also Dacono. And yeah, the Fernandina volcano in the Galapagos Islands, its lava flows getting closer and closer to the sea. Also Popocatépetl, Fuego, Machín in Colombia. Looks like volcanic alert level at yellow there. It could be fixing to erupt. Nevado del Ruiz also erupting. 20,000-foot ash plume there over Colombia. Sangay, Revenador, and Sabancaya all erupting. 7 magnitude earthquake drought continues. There are the past 90 days in a convenient bar graph form, thanks to volcanodiscovery.com for compiling that. These are the quakes of a 5 and greater magnitude, starting out with this one near Guam, a 5.1 early this morning. And then only about 14 minutes later at Kamchatka, the Kamchatka Peninsula there out in the Pacific Ocean, seeing a 5.1. 5.5 strikes a mid-Atlantic ridge in the Tropic of Capricorn. And then a lull in 5 and greater magnitude earthquakes until in the South Pacific we see Macquarie Island, and that is where the quakes end. And let's talk stats. The 10.7 centimeter radial flux now at 190 solar flux units. 190 is the current radial flux number. And pardon my wardrobe, my shirt is full of space. So there's the radial flux over the past year, represented by that black line. The red line is the sunspot number. Again, radial flux now at 190 solar flux units, having made it all the way up to 210, 211, 210 at least. So that is close to the peak we've seen in the solar cycle. Don't be surprised to see that go quite a bit higher in the coming 6 or 7 months. We're expecting solar maximum sometime around October. Space Weather Enthusiast Dashboard is forecasting continued geomagnetic storm conditions. We do indeed have an elevated solar wind velocity, but things have been pretty minor following that KP major geomagnetic storm last night, but it was quite short-lived. Just a rather rapid pulse there of sudden space weather. Since then, things have been subsiding. Also, just a quick reminder, if you haven't seen the ESA, the European Space Agency's new data portal, there is a new space weather data portal there available to the public. If you want to check that out, there's a new Enlil spiral that you may have never seen before, the Euphoria Enlil spiral. And let's take a look at Earth's magnetic moment from space. Again, heightened solar wind velocity going on here at the moment. The last 4 hours of Earth's magnetic moment from space have been fairly calm. So we don't see super strong fields or high density, so no major space weather there. That depicts magnetohydrodynamic pressure, the units of which are nanopascals. Here comes magnetic flux density from the ground level, changes to Earth's B field, otherwise known as geospace delta B. And if you saw some aurora last night, definitely let us know in the comments, or better yet, post it on Twitter, x.com/Smashomash, and tag Smashomash in your post. We will share your auroral imagery on the channel. KP index currently at 2.33. Again, like I said, it's a geomagnetically calm situation. Next, looking at the solar wind data, and check it out, the ACE currently has over 600 kilometers per second. 600 kilometers per second at the ACE there, but a very diffuse but very fast solar wind. So less than 1 proton per cubic centimeter for the density, solar wind velocity here, over 600 kilometers a second. Now the Discover, very different scenario there, although it is also a diffuse solar wind at only 85 hundredths of a proton per cubic centimeter. Solar wind velocity there quite different as well, 556 kilometers per second, make it 559. Looks like that CME might have just subsided in the past 3 hours. And next are GOES magnetometers, and there you can see that huge variation in the magnetic fields of the outer Van Allen belt, where the GOES 16 and GOES 18 measure the magnetic fields. That huge variation there, that was the onset of the coronal mass ejection impact. Since then, it's been pretty mild. The magnetic fields subsided rather quickly. So that's what's been going on. Here's our top view ecliptic plane field plot. And Earth has just recently snapped into a North Pole oriented sector. So if you look at the last image there, it's looking like it's showing no magnetic sector. So Earth is right now in a current sheet. Yeah, Earth, it's in a current sheet. The area between the magnetic sectors. But in any case, North Pole sector likely already here, folks. North Pole sector. Should only last a couple of days, assuming things remain as they currently are. Next, our line of sight field plot. And that's a lot of information in a little bit of area there. So very dense information there. Solar B field, photosphere magnetism, and polar fields all depicted for the past 4 days in our line of sight field plot, which brings us to our line of sight coronal hole plot. We do have some coronal holes rotating in here. They're now of North Pole orientation. Let's take a look at those from the SDO. We've included also the 171 angstroms wavelength here. So there are the past 24 hours. That coronal hole in your lower left, that is North Pole orientation. The one in the lower right is of South Pole magnetism. And let's move on to sunspots. Sunspots are important, right? So there you go. Sunspot number currently at 166, 167, something like that. And again, the likelihood of a large solar flare, folks. Look at that, an X-class flare, according to the flare probability scoreboard there, is more likely than even an M-class flare. So that is remaining a very magnetically complex sunspot group there, sunspot 3615. It's been exciting to watch its transit. Let's hope it makes another round after it sets in a few days. So very nice indeed. So that's what's going on for sunspots. And before we get to things like energetic particles, let's take a look at sunspots from SDO's continuum wavelength. Or it's a series of wavelengths, ultimately. So there you go. There's a 24-hour video, and these spots have been mostly stable for the past 24 hours. No major degradation, no major growth. There's a little closer view for you. Another 24-hour SDO video there. So sunspot number here to remain somewhat stable, it looks like, assuming nothing rapidly changes, which it is able to do between now and tomorrow. And before we get to any of that stuff, let's take a look at energetic particles and flares. The ghost proton flux here slowly returning back below warning thresholds to baseline levels. We did have one impulsive M-class flare. It was nearly an M5, and M4.47 was the peak flux at 6:40 Universal Time this morning. And how about some of our favorite X-ray bands? Of course, that's not technically X-rays. It's actually 94 angstroms, which is part of the extreme ultraviolet spectrum. It's just that that's the best wavelength, one of the best wavelengths through which to view solar flares. And again, sunspot 3615 in your lower right is indeed our T-mass for the day, the most active sunspot. We've also decided to show 131 angstroms today because, well, it was on my list of things to do. So, so there you go. Another 24-hour SDO video for you. And let's move on to solar system forecasts and a star chart. Yeah, a star chart. You got to have it. You got to have it, folks. So, and there you have it. That's where things are today, heavenly bodies. Besides the ones that are watching our video, here's where things will be in 1 week. There's your solar system forecast as Mercury swings around to this lonely side of the solar system to make another pass, long before Venus has a chance to catch up. Next, our star chart. This is what's going on over our head. If you want to make your own, skyandtelescope.org will work. Very nice, especially when viewed on a desktop computer. Skyandtelescope.org as the sun is at a setting mode over Lehigh Valley, Pennsylvania. Next is our astronomy photo of the day, and this one features audio. So let's show this one. This is an audible representation depicting the data in the Jellyfish Nebula depicted as raindrop sound or water droplet sounds. Here you go. Alrighty then. So that's a thing. Yeah, that's the astronomy photo of the day, apod.nasa.gov. If you want to check it out on your own. Sonified Jellyfish Nebula. Next, coronal mass ejections. Those are kind of important, right? We just got hit by one. NOAA thinks that there's an ongoing situation with them, but I'll just leave that there. Those are 69 frames from today. We do see a number of CMEs, at least 2 or 3 there. We'll do a further analysis here in a moment. So next we'll add the LASCO C3 in blue, basically a zoomed out version of the C2. Let me bring that back to show just today. So, what do you got? What do you got? We got one out of the west and one out of the northeast, kind of at the same time there. More of a flow out of the west and a CME out of the northeast. And then another one out of the northeast. So those are the things to watch. We'll also look at stereo A. We show that because it tells you where stereo A is located. And let's see if there's any chance of earthly directed action. I don't think so, but let's check. We don't anticipate those to be earthly directed based on where they originated from. But let's take a look at our composite imagery, because that's pretty good. Yeah, it's pretty good. So there you go. We've synced up the LASCO C3, C2, and the SDO imagery there. A little bit of missing data, not too bad. Let's get a little closer there. So there's the northeastern one. That's not earthly directed. The western one, not earthly directed from the far side. And then the last one, also out of the northeast, is not earthly directed. So here we've added the 193 angstrom 60-minute running difference imagery to show some fantastic detail in the corona there. A really lively scene happening. Lots of solar filaments right now on the Earth side of the disk. Dag. So, before we get to filaments, let's take a little closer look here in these wavelengths. 304 plus 193 angstrom 60-minute running difference. That's ionized helium and ionized iron. In other words, the difference imagery is iron star. There's the equatorial view. Great view of sunspot 3615. And there's the southern polar region. Filaments, filaments, filaments. We've got a lot of filaments. So that's where our custom imagery ends and our filament imagery begins. So let's do that next. Filaments from Cerro Tololo, Chile. So there you go. There are filaments. And like I said, a lot on the Earth side of the solar disk. Also prominence, a major prominence down there in the southeast, which would be your screen lower left. Let's do a brief count. What do you got? 1, 2, 3, 4, 5, 6, 7, maybe 10 filaments on the Earth side of the disk. That's pretty many filaments. And before we get to bonus features, here are the past couple of hours from the GOES 16 SUVI. And it is, again, a very high likelihood to see a large solar flare, including an X-class event from Sunspot 3615. Sunspot 3615 is pretty burly. It's pretty burly. Bonus features are next. Satellite charging hazards. We have some minor charging hazards there in the northern Indian Ocean. That is low energy electrons building up on the outside of spacecraft. GOES electron flux here is quite low, and we're expecting a major electron storm coming. There's the 1-year graph to contextualize it, and check out NOAA's forecast. Expecting well above warning levels there. A major electron storm is likely, and I would tend to agree. Now that's measured at the F layer of the ionosphere, so we'll show that layer's vibrational frequency as well. There it is, the F layer at 300 kilometers of altitude, and there is the fraught with low frequency anomalies there. So that might look a little differently than it normally does to you. Well, it's because there is a lot of low frequency anomaly. So that is the subsiding of the coronal hole high speed stream. Again, pardon the transparency of my shirt, but it is full of space after all. So you're going to see a lot of low frequency on there and not a lot of high frequency. And if you're not familiar with that, check out the anomalogram. That's anomaly in megahertz from a 30-day median. And you can see lots of low frequency anomaly on there. That is the aftermath of a major geomagnetic storm impact. So the ionosphere is still reeling from that. And we may see that continue here for another day or two. So that was definitely a strong impulse on the ionosphere, that KP8 moment, accompanied by strong magnetic fields, especially, were the main culprit. So material plasma is making its way into the Earth system. So that's what's going on in the ionosphere. We'll also show the global ionosphere nowcast. It's pretty sweet. It depicts total electron content and maximum usable HF radio frequency all at once. and the anomalies in those two things. So GPS users and radio users, that's for you. And to quote Nick Burns, your company's computer guy, you're welcome. It's almost time to get to weather. But first, the latest high-res images of Sunspot 3615. Before it goes berserk, here's some more imagery of it. Yowzers! That is a magnetically complex sunspot group indeed. So it's Beta Gamma Delta class. That is the most likely class to produce a large solar flare. So let's move on to meteorology, but first, take a moment to press like if you enjoy the content. If you're new to the channel, do yourself a favor and press subscribe. Get the world's most comprehensive daily space weather content delivered right to your YouTube subscription feed, or get involved by visiting the links, or leave a comment, or do absolutely nothing and contribute in no way to the channel. We consider this to be a group effort, by the way, so thanks to all of our viewers who have helped the channel out by pressing the share button and so forth. Here comes meteorology, and we're starting out with this massively powerful low pressure off the coast of the eastern U.S. there. So check it out. That's a strong low. That's the mean sea level pressure and surface winds, folks. And it's showing you a great example here of how low pressure systems suck and high pressure systems blow. So yes, the surrounding air gets drawn into a low pressure system, and a high pressure system is a force from above pushing down. So of course, as a result of the pushing down, air is forced out of the high pressure zone and into the low pressure zone, because lows suck and highs blow. So those are just, I'm not being vulgar, those are just facts. And here come our regularly scheduled meteorology segments. Surface winds of the east and the jet streams. Shout out to our viewers from that side of the planet. Shout out to our viewers from this side of the planet. Jet streams, surface winds. Surface winds of the western world. Shout out to our viewers from this side of the planet. Strong winds across Mexico right now. And there are the jet streams for the Americas. Next, satellite imagery. And there's some major kinks in the jet stream here across the U.S. That's what's bringing a cold snap across the country. It's just crossing into the Mississippi Valley right now. And it is currently around the Iowa-Minnesota border. That's your visible satellite from the GOES Interactive Weather Satellite Suite. And once again, we're looking at pressure here. So we've got quite a lot of low pressure over the U.S. here, especially the western part of the country. Eastern part of the country's got clear skies and high pressure, but there's a cold snap on its way in. Once again, it has to do with the jet stream. That is once again, it's the pressure at sea level there, folks, from windy.com. Next, our weather.gov map, and there are quite a few weather warnings. If your location is lit on the map, well, head to weather.gov and visit your own weather warnings. Here come some forecasts. So that's pressure and precipitation for the next 72 hours, GFS model. Next, accumulated positive snow depth change forecast in inches, 72-hour GFS model. Next, the jet stream forecast, 72-hour GFS model, 250 millibar winds. You can see that huge kink pulling cold Canadian air down south as that cold snap makes its way east. The jet stream, it's the culprit for most of your weather patterns, at least major ones, where your weather has a tendency to move from west to east. Last but not least, temperature anomaly forecast in degrees Celsius. Same model, GFS 72-hour. And you can see that cold snap making its way. Actually, it's making its way north, so that's a good thing. We didn't really want the cold air here in Pennsylvania. It's feeling more and more like spring, and we'll take it. I'm ready for winter to be completed. Next, lightning. And that's where it's been striking for the past, 10 hours. And do we have any terrestrial strikes? Here's our real-time lightning map from lightningmaps.org. And let us know in the comments if you've used lightningmaps.org to see if it's safe to do whatever you're doing. It's fantastic. There's some active lightning there in Iowa. Again, as that low is right around the Iowa-Minnesota border right now. Also the Gulf states, south of Memphis. The Oxford Airport is experiencing being surrounded by thunder cells, or lightning cells, or whatever you want to call them. So some heavy precipitation here across Missouri and Arkansas, especially making its way toward Chicago. Here's a brief view of the full 50 states. We'll be focusing on the lower 48 for the remainder. There's your satellite imagery. You can see that system bringing blizzard warnings to parts of the U.S. And there is the water vapor map. When your Doppler's unclear, try that. Here's our recap. Doppler radars first. There is snow to the west of the Mississippi. Satellite imagery is next. That's the visible satellite. And there is the water vapor map. And here is me signing off. And some well wishes for each of you. May that solar wind be at your back.